Sorry, it's a new computer. I'm hoping everything is working, but if not, my apologies to people watching online. Thank you, everyone, and thank you for the warm greeting here in Warsaw, in Poland. My name, of course, is Stephen Downs. This is my first talk in Poland, ever. So thank you for welcoming me. It's a real pleasure to be here. My talk is called Becoming Connected. And I'm not sure if it translates exactly into Polish, probably not, but becoming connected has different senses to it in English. It's the idea of personally becoming connected. It's the idea of the process of becoming connected. It's the idea of the result or the consequence of becoming connected. Silly thing. Sorry, I'm fighting with my presentation. My presentation is winning. There we go. There we go. Now, I am victorious over my computer. It's sometimes a close thing because as computers get better and better, they become smarter and smarter, and soon they will outsmart me. Won't be long now. So here is my objective for today. The objective is, as suggested in the introduction, to present the core ideas of connectivism. And I want to do this in both a learning and a scientific context, out of respect for the location where we're holding this conference. And in a sense, to bring together or unify the concepts and ideas of discovery, interaction, and education. Some of these are very old ideas. I don't claim to have originated them. Some of them are new ideas. Most of it is bringing together things that we already know and showing them in a new light. So here's the overview of what I have in mind. I'm going to ask two core questions. The first, with which I'll begin the talk, what is science? And it's a question that we might think we have the easy answer to. And certainly in the domain of education, a lot of people feel they have the answer to it. But it's a harder question than may be first thought. The second, and the one that you're here for, so I'm told, what is connectivism? I'll talk about some of the ideas underlying that theory. And we'll bring these things together to look at the question, how do we learn? Because this is what we're trying to study in the field of education. And then I'll draw out some implications for practice. What this theory of how we learn means on a day-to-day basis as we go about our usual practice of teaching and, of course, of learning. So let me outline these very briefly, and then we'll look at them more in detail. So first, looking at science. And what I'm going to do is think of science, the core idea of the science, the core idea of learning a science, and the core idea of being a practitioner of a science. To learn that discipline is to become, importantly, like or similar to other practitioners of that science, of that discipline. Lucas was communicating with me before the talk, And he pointed out to me the difference in the conception of science in North America, where we have this concept, STEM, science, technology, engineering, and mathematics, and science more broadly conceived as the various disciplines, medicine, philosophy, perhaps even a science of art, perhaps a science of language. I construe science more broadly. I'm not thinking of science in the narrow sense of physics or biology or chemistry, or the way we might think of it normally in North America. In my own mind, science is a much wider discipline, and we'll see some examples of that. Connectivism is the next core idea that we'll look at. And this is the idea that knowledge literally is the set of connections between entities. And that's very carefully formulated. And that learning is the growth and development of those connections. That sounds like a simple idea, but when you take this idea seriously, as George Siemens did and as I did, it results in a very different picture of knowledge and indeed of science than the one we're used to. And so this takes us to what we think, what we believe learning is. And this is a proposition. It's a hypothesis. It's something that is to be shown over time empirically. It may prove to be true, it may prove to be false. We believe it is probably true, and we believe there is evidence for this. The idea is that we learn and grow by becoming connected, hence the title of the talk. And becoming connected means, in one sense, to grow and develop connections in our mind, but also, as suggested in the introduction, becoming connected is to reach out and connect with each other in a community, or in a community of communities, in a society, in a culture. And so we have personal knowledge and we have social knowledge, and these equally are parts of knowledge. And importantly, it is an additional goal of both science and education to foster and grow and develop those connections. Arguably, depending on what day it is, I might argue this way, it is the only goal of education and science. So these are, abstract, theoretical thoughts. They can be difficult thoughts. The practical aspect of connectivism is how this is realized in practice. If we take seriously the idea that to know is to be connected, to learn is to become connected, then what does that mean for our teaching, our practice, our own learning, and our own development? I'll talk about something called the ARF process model. I named that after Alan Levine. His nickname is Cog Dog Blog, so dog, ARF, okay. It works really well in Canada. Talk about the success criteria, and I'll talk a bit more about the actual practice of learning and development. So that's the overview. That's what we're up to today. So let's begin with, what is science? I thought I'd be speaking there today. So as it turns out, I took a picture of the wrong Copernicus. I hope that's okay. I didn't know there'd be more than one. So, what is science? We think we know, right? It's people in white lab coats with funny hair and chemicals. And no. A lot of the time, and historically, we think of science as a domain of discourse. And what does that mean? Well, in a science that's characterized as science, say physics or mathematics or whatever, we have a set of objects that we're talking about. You know, in biology, we talk about plants and animals. In mathematics, we talk about numbers. In philosophy, we talk about ideas, things, right? And then we have the set of properties that these objects might have. An idea is good. A bug is yellow. A person is sick. Whatever. So that's what defines the science. The different sciences have these different objects and these different properties. And so we have someone like, say, Rudolf Carnap, who is perhaps under-recognized. He certainly is one of the major figures in the philosophy of science and indeed of science generally of the 20th century, coming up with what he writes are the logical foundations of probability. But it's also the logical foundations of science. And you take these objects and you take these properties and you think of all the different possible properties all the different objects can have. It's an astonishing thing to even think about. But, you know, we can do it here. Right? Let's take our domain of discourse is all the people in this room. So what are the properties you can have? Well, you might be male or female. You might be old or young. You might be wearing blue or wearing brown, etc. You know, white hair, gray hair, yellow hair, brown hair, red hair, whatever. And in our mind, anyways, we can imagine all the different possibilities. And of those possibilities, we can extract a set of statements. PA, the property P is had by the object A. That's really abstract. So what does that mean? It means Fred is tall. QB, Shirley is short. RB, Frank is short. SC, Lucas is here. He is here, right? Did he leave? Okay. So the idea is, out of those, all the logical possibilities, we have some actual states of affairs. And so this is the basis of science, to study these things, to study what properties they have. And so we extract from this the principles of what has been called the deductive nomenological model, which is a ridiculous name, blame Carl Hempel. But the idea is we observe states of affairs in the world. It's the basis of science, right? We go look at things. If Alex is red-haired, then Judy is brown-haired, or whatever, right? We have an observable relation between entities. And then we hypothesize. We try to come up with a generalized statement about the world. For any given objects, X and Y, if X is a P, then Y is an R, or whatever. Just some general principle. But of course, anybody can come up with a general principle, right? Einstein did, Newton did, my friend Freddie did, all kinds of different principles. We have to test the principle. So we make a prediction based on that principle, and then we go out, we do some experiments, and either the principle is confirmed by the evidence, that's Hempel, or if you like Karl Popper, we try to falsify the principle. And that's science. And that's the model that people use, or have used. That's still the model that is used by people in education today. I would argue they should not. But that's what they think. They go out, they do experiments with students, give the student this kind of instruction, then they'll get this kind of test score. All right? These kind of teaching methods produce these kind of outcomes. How do we know? We went out and we made a prediction, we tested some kids, and there you go. There's all kinds of that kind of research. There's the Organization of Economically Developed Countries, OECD, has what they call their PISA tests, Program for International Students Assessment. You may have heard of that. This is what they're doing, this kind of model. They're trying different interventions, and then they evaluate students at the age of 15 for certain educational outcomes, and they say, aha, the students in Finland are doing really well, their theory must work. The students in Canada are doing really well, their theory must work. The students in Mexico, not so good, it must be their fault. Okay. But science does not really work that way. You may have learned this, but this is not how it works. This model is basically what we call logical positivism. And if you're familiar with the theory of behaviorism, that's part and parcel of logical positivism. And the idea of logical positivism is that we have an observation language, statements of empirical fact. I went out and I saw a dog and the dog was gray, for example. And then we have analytical statements, the principles of logic, the principles of mathematics, which are guaranteed, certainly true, and true independently of any knowledge, any experience, any empirical fact. And then, of course, the general principle that we try to derive from the observation and the analytical principles. That's the model. It fails. And it fails for two reasons, nicely summarized by Klein in a paper called Two Dogmas of Empiricism. And the first point of failure is that the principle of reduction is false. Remember those nice observation language statements, PA, QB, RB, etc., that are supposed to be the foundation of all knowledge? In fact, knowledge does not reduce to those. We cannot reduce all of our knowledge to statements of personal observation. As some people say, the experiment underdetermines the theory. The second problem is there's no analytic synthetic distinction. The principles of logic and the fact of observation are not two separate domains, they overlap into each other. We've seen this in a lot of the discussion that has taken place over the last 50 years in the philosophy of science. Larry Lawden, for example, and others, talking about the way data is theory-laden. This has been one of my criticisms, not just mine, but many others, of the PISA test, right? What you see in the world depends on what you're looking for. If you're looking for dogs, you're going to see dogs. If you're looking for spirit-like emanations of dogs, you're going to see spirit-like emanations of dogs. It all depends on what you think is there, is what you're going to actually see. And these theories combine to form what Thomas Kuhn called paradigms. And a paradigm is more than just a theory about the world. A paradigm is a way of seeing the world. If you were living in, say, ancient Greece, colors would be different for you than if you're living in 21st century Europe. The ancient Greeks did not have red, orange, yellow, blue, green, purple. They had darkish red, lightish red, bluish green, purple, orange, and yellow. Okay, I'm making that up. But they saw colors differently than we see colors. They saw the world differently, the words that they used. George Lakoff, in a book called Women, Fire, and Dangerous Things, talked of a particular society that divided all of the world into two categories. In one category is women, fire, and dangerous things. And in the other category is everything else. And that's how they saw the world. So science isn't just observation to theory. Science is way of life, as Ludwig Wittgenstein would say. Science is the practice, the commonly accepted ways of doing things. This is why you spend so much time in a lab, because you're learning the way of doing things. Science is a common understanding of what the questions are. And different sciences have different questions. And what counts as evidence and what doesn't count as evidence. And as an aside, in education, in the discipline of education, these are the points where we do not have agreement. We do not have agreement in the field of education on what the practices are, on what counts as evidence, even on what the objectives are of the domain, what we're trying to do. Science results in community, like a community of inquiry, depicted one on the screen here, where the community of scientists is almost indistinguishable from the science itself. What is physics? Physics is whatever physicists do. What do physicists do? Well, you have to join their community and become a physicist in order to find that out. I know it sounds really circular, but that's the way it is. This is a map of the sciences. It's a real map, not made up. And the way this map was created is the authors looked at all scientific journals, all of the journals, and all the articles in those journals, and looked at the references in those articles to papers outside the domain. So, for example, they looked at a physics paper, and if the author referred to a paper in mathematics, they took note of that. Or if the author referred to a paper in medicine, they took note of that. And so each dot on that map, I'm pointing here, but it's up there. Each dot on that map is an identifiable scientific discipline. And the lines between those dots represent connections as evidenced by references in scientific papers from one discipline to the other. That's what science is. Multiple domains of discourse, all interlinked, multiple communities, all interlinked. different questions, different methods, different ways of seeing the world. It's almost frightening, isn't it? So there are different ways of thinking about what's going on here. One prevalent theory in the philosophy of science, and by prevalent I mean now, today, this is what a lot of people think, is that science is actually a process of construction. There's Bas van Fraassen, who wrote in 1980 about constructive empiricism in his book, The Scientific Image. And recently, David Chalmers, in a book called Constructing the World, again, it's the same idea. But what is it to construct? It's to build a model, a representation. But what is this model or representation going to be made of? Well, if you read Van Fraassen, you read Chalmers, you're back to Carnap again. You're back to the idea of a science as being a representation or model constructed out of statements of possible states of affairs in the world. We're back to observation language, we're back to properties, we're back to universal principles. We've come full circle. I think we're at a point of decision in a historical sense when we ask, what is science? Is science really construction? If so, then we think that science has a foundation in language, in representation and models, and that it's something that we make or create? Or is it something different? I wrote down there, science as discovery. Maybe that's not the right word, but the idea of science as having a foundation in experience, in immersion, in practice, throwing spaghetti at the wall and seeing what sticks. Science not as something that we make, but something that we become. Instead of creating a community, we grow a community. Instead of creating a model, we grow a model. But what does that look like? That's part one. Okay. That's the problem. That's the world that I found myself in, George found himself in. That's the world of education, trying to figure out how do we learn, how do we think, how do we grow, what should we do with this thing we call the internet? And our answer, it's not a precise answer, but our answer is connectivism. So let's think about that. Connectivism begins with something called connectionism. That's where it began for me. For George, it's a bit of a different story, but that's where it began for me. Connectionism is a theory in computer science. In 1980, 1990, when I was researching this, it was kind of one of those way out there theories. Today, it's almost mainstream. And the idea is to develop artificial intelligence systems modeled on the way a human brain works. So, how does a human brain work? Well, this is a rough, very rough abstraction of it, where you have those little round circles, we'll call those neurons, or nodes, or units, or as I prefer to say these days, entities. and then connections between those neurons. So, and we have layers of these connections. So, what this is in computer science originally is a network-based, non-symbolic-based processing system. That's a horrible mess, but it's a neat idea. And today they're using these things to do all of the artificial intelligence stuff that you read about, computers that play chess, systems that read tweets and tell you whether you were happy or sad. They are all based on variations of connectionist systems. So this idea proved to be practically useful. The big difference between connectionist systems and other systems is the way they represent the world. And in a nutshell, one of them is symbolic, the other one is not symbolic. The symbol-based system is on your left, where we think of a model and representations based on sentences and words. The Carnap kind of model, if you will. The type of model I described in the sciences. On the right-hand side, there are no labels. It's not based on language at all. It's just connections between entities. Now, what's really interesting is that if you think of knowledge as the connection between entities, then you can use the same network to represent multiple things. This is a complex idea, but it's a core idea. Here's what I mean. We think of an idea as having a certain location. But in fact, our ideas are spread out across the system. Think about, for example, how to fly an airplane from Toronto to Warsaw, to pick a local example. No one person knows how to do that. No one sentence or book or anything describes how to do that. Think about what it takes to fly an airplane from Toronto to Warsaw. You have to know how to build an airplane. You have to know how to build tires, windows, entertainment systems, navigation systems, all the parts of an airplane. You have to know how to fly an airplane, how to take off, how to fly, hopefully land. You have to know all the tasks, air traffic control, serving coffee to people, safety instructions at the beginning of the flight. All of these things put together constitute the idea of how to fly an airplane. But there's a bit of it here, a bit of it here, a bit of it here, a bit of it here. All of our ideas are like that, not just some. In the picture there, I have a picture of a couch. In our brain, we don't have a couch, clearly. We don't have a picture of a couch. We don't have the word couch. We have this neuron, and this neuron, and this neuron, and this neuron connected together. The knowledge of a couch is distributed. The knowledge of a dog is distributed. The knowledge of a tree is distributed. And they're all distributed in the same network. So the idea here is that in connectivism, knowledge, concept, ideas basically are the result of linking together individual entities to create a pattern of some sort. It might be linked data, which is the example there. It might be linked neurons. It might be people connected to each other. It might be crickets chirping at each other in the night. Different entities connected together in a characteristic way. That's a really abstract idea. George and I tried to explain this idea, much like I'm trying to explain it here, and nobody understood. We didn't understand. It was almost hopeless. So what we decided to do is we decided, okay, let's create on the internet the sort of thing that we're talking about. So the first instance of that is what we might call personal learning environments, personal learning networks, personal learning knowledge. And it looks like that diagram there. Now this is something that's more concrete. We have a person there in the middle, and we have the different tools that the person uses, RSS, an online library, Wikipedia, etc. But we also have the networks of people that they connect to, the writing that they do, the professional development that they do, the communities that they connect to, Facebook, Twitter, Meetup, whatever. Some things that no longer exist, like Maine, or organizations, etc. So we see that for an individual person, their knowledge is actually stored in a network. George said sometimes, I store my knowledge in my friends. But the idea here is that what I know isn't just in my head. What I know is distributed across a network of connections. So we tried that. Did that explain it to people? No, it did not. So we tried again. We developed something called the Massive Open Online Course. So what we did is we said to ourselves, well, we said, first of all, let's have a course in connectivism. And then we thought about it for a bit. We thought, but nobody's going to understand the lectures. So, okay, we'll have a text. And we thought, well, nobody will understand the text. And I asked you, right, how's it going so far, right? It's a hard concept. So we built a course, but it could not be a standard kind of course. We built a course that was a network. And that's what it looked like on day one. And the idea was that we had some of the content here, some of the content there, some of the content on Twitter, some of it on Google, some of it in a weblog, some of it in a discussion board. And then we invited people to come join us, and we said, instead of you reading content and memorizing it, what we want you to do is find content or create content or whatever, and then use that to communicate and interact with other people in the network. So it wasn't just setting up the network, it was creating traffic in the network, making the networks come alive. And that's what happened. And we thought we would get 25 people maybe. I mean, after all, we were offering a course in connectivism, which nobody heard of. We got 2,200 people, which greatly surprised us. But because the course was structured as a network, it could grow instantly. And so we had no problem having 2,200 people in our course. It was easy because the course was the network. It wasn't the content. It wasn't, PA, RA, SQ, etc., things you have to memorize. It was the interaction. It was the community. It was the science understood as practice and interaction and dialogue and process. It's really hard to get your mind wrapped around that. But this thing that we started, it created a community that exists to this day. It spun off. People at Stanford created MOOCs and had hundreds of thousands of people. Companies grew up, Coursera, Udacity, etc. The idea took hold. And that's the way science works too. It's an idea and a community that grows and then becomes its own thing. Instead of a course as a series of content to be presented and remembered, we envision a course as a network of participants who find and exchange resources with each other. Now ask yourself, what is the intended outcome of that course? Is it to remember content? No, because there's no content. It's to become a part of this network. And by becoming a part of this network, to become like other people in the network. Make sense? A lot of work just to get to that. So that's what we did. We built the initial structure. We seeded it with some open educational resources because we had no money. We did this with no money. We still have no money. MIT got all the money. Stanford got all the money. We're still broke. And then we encouraged the participants to add their own resources. And we created a mechanism. I wrote some software called Grasshopper to connect everybody together. Because you have to have a way of connecting people. And we built a community. Just like the community of science. What we built as a course is what science has become today. It's very different from the old model. So you have the old way of learning, the old way of science based on memorizing facts, the new way of learning, the new way of science based on communities. Communities of practice, communities of domains of discourse, communities of connections between members. So that's where we were. What do we conclude from that? Well, we face the same dilemma in education as theorists of science face in science. What is learning? Is learning construction or is learning discovery? A lot of people say learning is construction. They are called constructionists or constructivists. I go a different direction. I think that learning is discovery, and maybe discovery is the wrong word. I'm reminded, of course, that the whole concept of discovery learning is something that has been around forever, and that's not quite what I mean. Learning is not discovering general principles, it's not discovering content, it's not discovering how to solve problems. Learning is more like becoming like a scientist, becoming like the sort of person that you want to become like. Maybe I should say construction versus becoming or something like that. Language is hard. But we have this point of decision. So, what is it for a network to learn? I said earlier, learning is the growing and creation of connections between entities. Remember that? So you have a network. How does the network learn? You create connections between the entities. But how do you create connections between the entities? How do we create relations or links between each other? How does a computer system, a connectionist system, create links between neurons? It's the same problem in every case. And, well, by now, there's an entire field of literature devoted to this. It's called learning theory. And it's not in education, it's in computer science. It's kind of interesting. But if I had to categorize the different ways of creating connections between people or entities or even cricket, there's three major things that I would point to. One is a principle called Hebbian associationism, or the off-the-cuff, common sense way of depicting it is birds of a feather fly together. Does that translate into Polish? No. It's the colloquial. This language is so culturally bound, right? It's hard to represent it. How about, sometimes in psychology, they say, what fires together, wires together. Any better? No. Worse. So, okay. So here's, instead of using a nice pithy slogan, if this thing has a property and this thing has the same property, then they're likely to form a connection. Things that are similar form connections between each other. There's a word, a technical word for it, homophily or homophily. It's the idea of people who are the same as each other tending to form groups themselves. So, and that's a principle not just in society, it's a principle in psychology and in computer science. And it's been observed to happen. I'll bet you most of the people you know are people who are similar to you. They speak the same language. They live in the same city, or at least the same country. Right? They're similar to you. That's one way. A second way is a thing called backpropagation. It's a complex concept, naturally, but the idea is this. You set up a network, and then you feed data into one side of the network, and data comes out the other side of the network. And then what you do is you look at that data that came out and you say, was that correct or was that incorrect? And if it was incorrect, you send it back. And it goes back through the network and makes corrections all through the network. It changes the connections. It's feedback. But it's feedback at a low-level kind of technical sense. If you ever hear about people who are doing learning analytics or artificial intelligence talk about training sets or training runs or training data, this is what they're talking about. They're training a computer system how to recognize something, a good response, a happy customer, whatever, by using data and correcting the network until the network is able to get the right data out the other end. You may have seen automatic course grading software, or you may have heard of that. This is how that works, right? What you do is you get a whole bunch of already marked papers. They all have a grade, A, B, C, D, E, or whatever, right? And that's your training data. And you feed that into the network. And then you give the network a new paper And the idea is that the network tries to identify whether it's most similar to an A, B, C, D, or E. And if it comes out incorrect, you send it back. And you keep training it until eventually the network is able to recognize this is an A paper. Not based on any properties or anything like that, but based purely on the structure of the network and the training that you put the network through. So basically, we train computer networks to grade papers by giving them practice grading papers. That's how it works. Put that way, it's a really simple idea. The third way is a way that isn't used a lot, therefore my personal favorite, the idea of Boltzmann settling or annealing. And a way of thinking of that is your network has a certain structure, but what your network wants to be is as stable as possible. And so to train the network, you give it data and that shakes it up, and then the network settles into the most stable state, and that's how it trains itself. Okay, different ways of training networks. This could be an entire course, not just a talk, but an entire course. So, network learning is the development of these networks. Pure and simple. It's the creation of the links that make up a network. For a person, it's creating the links in between their individual neurons. For a society, it's the creating of the links between people, the communities of practice. It's based on experience. You train a computer system to grade papers by having it practice grading papers. You train a person to fly an airplane by having them practice flying an airplane. You train a person to do brain surgery by having them practice doing brain surgery. Hopefully not on real people, right? Maybe on simulations or on already dead people or whatever. Learning in this model is not memorization. It is practice and reflection. And on this model, to know isn't to be in possession of a fact, it is to recognize. So, I'm going to skip that one. Think of it like this. Another horrible, messy diagram. Well, what's happening here is when you're given different data, you come out with different results. Give the network some kind of data, you think one thing. Give the network different data, you think something else. Learning is very similar to that. In fact, it is exactly that. When you create the network, you acquire the capacity to recognize. You acquire the capacity to see the world as somebody in a, you mentioned family. Being in a family is learning. We don't teach it in school. It would be impossible to teach at school. But what is it to be in a family? Well, one simple example is if your grandmother comes and visits and you go to meet her in the train station, you're able to find your grandmother and not some stranger. How do you do that? The simple answer is, over time, you have interacted with your grandmother many times. So when she comes through the train station, you recognize her. How do you recognize her? When you see your grandmother, a particular pattern of connectivity comes up. That pattern of connectivity is your model of your grandmother, your representation of your grandmother. She comes in, you go, ah, grandmother. And it's that simple. Now, did you memorize rules on how to recognize your grandmother? No. It would be silly, right? You couldn't possibly do it. What if she changed her shirt? Right? What if she colored her hair? You'd never be able to figure it out. No. Do you go through drills where you memorize the members of your family? No. You interact with your family. You have your own characteristic ways of talking, your own characteristic ways of being in the world, so that when you're out there in the world, you recognize them. You see the world the same way, you respond to the world the same way. This is the core of learning and discovery. Two concepts: recognition in one direction, emergence in the other direction. Patterns in the network create emergence. When the network creates patterns, you recognize them. Okay, hard concepts. What is emergence? Emergence is a network phenomenon. It's the creation of order in a network. It's a way of a network organizing itself. It's kind of a Gestalt way of thinking of things. On the top picture there, that's a thing called a murmuration. What it is, actually, is a bunch of birds. A flock of birds. In this case, blackbirds. And you've probably seen flocks of birds fly in the sky. Is there anyone in charge of those birds? No, right? There's no head bird. They're not following rules. They have not memorized content, and yet they are organized. The birds self-organize. They create patterns simply by acting like a self-organizing network. When we see order in that pattern, that's emergence. And our perception is like that kind of emergence. And that's the other part of it, is recognition. We recognize patterns in the network. This example here is famously called a duck-rabbit. How many of you see a duck there? How many of you see a rabbit there? Who's right? No. No one and everyone, right? So, what you see depends on your prior state of mind, what you were expecting, maybe what you were hoping to find. Technically, it's the activation of patterns in your mind, whether it was a duck pattern or a rabbit pattern. And in fact, you have both patterns that can go back and forth. So, learning and cognition generally are processes of emergence and recognition. Your network or a social network or whatever will organize itself and exhibit a certain pattern. And then you as a perceiver recognize or perceive that pattern. But the only way to perceive that pattern is to be in the environment where that pattern is being generated. Okay, enough theory. I'm trying to think of how that picture ties into practice, whether it's either drinking or stabbing a strange animal. I don't know. So, let's take these core ideas and turn them into practical application. And if you will, in a sense, uniting the ideas of discovery, interaction, and education. First of all, the idea of method as discovery. Not discovery learning in the 1970s sense, but to discover something in the sense of being immersed in something, being immersed in environment, being immersed in a domain of authentic practice, speaking and listening to people working in that practice. The best example of this that I know is language learning. And if you think of different ways of learning language, one way of learning a language is to memorize all the different verbs and all the different words. You may have learned a language that way. If so, I'm sorry for you. Or the other way, and I speak from personal experience, the much better way is to be in a community of speakers of that language and try to work and learn and live with that community on a day-to-day basis. And my experience is, and most people's experience is, it's really hard to learn language working from theory and rules and vocabulary lists. And it's much easier to learn a language by becoming immersed in and practicing that language. But that method works not just for language learning, but for astronomy, which is why we have children with telescopes rather than just telling them about telescopes. It works with medicine, which is why we have interns working in hospitals and not just textbooks. It works for driving, which is why we train people to drive in a car, or maybe in a simulation of a car, rather than just giving them a book and say, here, read this book and you will learn how to drive, right? So that's the first part of it, method as discovery. To immerse oneself in the world is to try listening and to try speaking in the language of that domain or that discipline. So that's the first part. The second part is what constitute the principles for effectively setting up that kind of environment. So before I go to the slide, the idea here is that this environment in which we're immersing ourselves is a network. It's like this community of practice that I've shown the slide a couple of times. And the principles come from defining what kinds of networks work best. What is it for a network to work? Well, there's communication. It's dynamic. It can change. It can grow. It can develop. It does not stagnate. It does not become dead. So, how do you build a good network? I've identified 4 principles. It's, again, a question of empiricism, right? Maybe these are the right principles, maybe not. Here are the first 2. Autonomy and diversity. In a network, as opposed to, say, in an army, each member of the network is autonomous. They make their own decisions. They have their own goals or their own objectives. They decide for themselves what counts as good. As John Stuart Mill said, it's the liberty of each person to pursue their own good in their own way. Autonomy, in a technical sense, means using your own device, using your own software, diversity in these choices. Autonomy in a social sense means having your own point of view, having your own conscience, having your own beliefs, etc. There are many ways to describe it. Again, I could spend hours talking about autonomy, different principles of autonomy. That's the first. The second principle, and it kind of follows from the first, is diversity. A network composed of diverse individuals is more effective than a network composed of the same kind or the similar or identical individuals. And if you think about it, it kind of makes sense. Suppose you're in a group of people, say, at a party, and you all believe the same thing. Well, what are you going to talk about? There's nothing to talk about. Suppose you've all had the same experience. What are you going to talk about? There's no story that you can tell that everyone else doesn't already know. It's through diversity that we have different points of view and therefore something to talk about. There's the story of the story of the wise men, the blind wise men, and the elephant. And each person experiences the elephant in a different way: a tusk, the trunk, the skin, the ears, etc. If they all touch the tusk, they have nothing to talk about. But if each person touches a different part of the elephant, then they have something to talk about. Diversity creates interaction. Diversity creates dynamism. Diversity creates the possibility of growth, development, and change in the network. The third and fourth principles are openness and interactivity. Openness, well, there are many ways we could talk about openness. Openness in membership. People can come into your network and leave your network. Openness to ideas. Ideas come into your network, ideas go out of your network. Openness to different kinds of technology, different kinds of ideas. Openness in the sense that the resources that you use can be accessed and used by different members of your network, but there isn't ownership or control over the communication of the network. And if you think about it, if a network is based on communication and interaction between the individuals, you have to have a mechanism for that communication to happen. You have to have a language. And the only way a language can function is if it is open, if everybody can use it, if everybody can shape it. And then finally, interactivity. Interactivity in the sense that the communication in your network flows not just in one direction, but in two directions. Interactivity in the sense that an idea can come from any location in the network and not from single privileged members of the networks. Interactivity in the sense that people are more or less equally connected to each other, rather than all connected to one or two individuals. So these four principles, these are principles, on the one hand, for choosing technology. Choose technology that promotes autonomy, openness, interactivity, and diversity. There are principles for designing structures, social structures, communities. There are principles for recognizing when your classroom or your company or your organization is functioning well or functioning poorly. If everybody in your company is speaking the same language and comes from the same background, that's a sign of difficulty. If you're doing artificial intelligence and your training data comes from a single non-representative sample, that's a sign of a problem. You want your training data to be diverse. You want your training data to represent many different points of view. So these four principles describe the principles of successful networks and their design principles. Process. How does one learn in a network? How does one teach in a network? The model here is, what is it to be a neuron in the network? For a whole year, I went around saying to people, be the neuron, be the... Yeah, they got sick of that. But the model is what we call the ARF model. Aggregate, remix, repurpose, feed forward. Aggregate, seek out connections from other people. Remix and repurpose, bring their content, their messages in, reshape it, remix it, repurpose it, make it something of your own. And then feed forward, send it to other people, share your knowledge. These are principles for life, right? These are principles that describe what I do as a scientist every day. In fact, they are, to me, what science is. Now, we have this model in corporate learning, the 70-20-10 model of learning and development. It's focused on experience more than anything else. You'll see it all over the place on the internet. What I'm giving you here is the 70-20-10 model of cognition, where 70% is based on recognition, being like a network. And reasoning and remembering form only a small part of the rest. 70% based on experience, practice, reflection, creation, and sharing, and only 20% on models, inference, representations, and theorizing, and even less on facts, data, names, and content that you have to memorize. Because the world isn't neat, like a nice Carnappian picture. The world isn't composed of state spaces and propositions and language. It's messy and complex, and there are many ways of seeing the world. It's not like there's just one language to talk about the world. It's like there are many ways of talking about the world. Many languages, many domains, many disciplines, many ways of seeing. Not one way of being, not one way of acting, not one way of representing, but many. And ultimately, that's what learning is, and ultimately, that's what science is. And that's my talk. And I thank you very much for your patience and for your time.
Dziękujemy. Thank you very much, Simon. Jak zwykle w takich wypadkach bywa bardzo mocno zjedliśmy czas na pytania i odpowiedzi, ale mam dla Państwa pocieszenie. W czasie naszej żywej biblioteki, oczywiście, Simon będzie dostępny w postaci czytelni, więc niemalże na żądanie. Będzie wiele miejsc, wiele krzeseł, na których będzie można usiąść, rozmawiać z Simenem. To będzie bardziej taka bardziej społeczna interakcja. W związku z czym obawiam się, że będę musiał Państwu jednak zabrać czas na pytania, dlatego że mam pewne ważne ogłoszenia. Ogłoszenia są generalnie 3. Pierwsze, w swoich torbach macie broszurę z programem, który znajduje się także na identyfikatorach. W związku z czym zawsze jest przy Was program minutowy. Druga informacja dotyczy tychże identyfikatorów. Spójrzcie na nie, proszę Państwa. Większość z Was ma tutaj taką literkę. Kto nie ma tej literki jak klawiatury? Ci z Państwa, którzy nie mają tej literki, wybiorą sobie zupełnie swobodnie miejsce w kawiarni idei i w ten sposób znajdą swoją literkę. Kawiarni idei dopiero za jakiś czas, to zgodnie z programem, natomiast teraz druga informacja. Zauważyliście Państwo, że jedne identyfikatory są takie purpurowe, a inne są granatowe? To ma znaczenie właśnie w tej chwili, ponieważ podzielimy się na dwie grupy, dwie różne połowy, mniej więcej. Jedni ci granatowi, przepraszam, od fioletowych, bo tak to tam jest. Ci fioletowi biorą się teraz tu na dole za chwilę i pójdą ze mną egzaminatorem do planetarium na stronę pedofilową. Biorą się teraz tu na dole za chwilę i pójdą ze mną egzaminatorem do planetarium na stronę pedofilową. Biorą się teraz idę na dole za chwilę i pójdą ze mną egzaminatorem do planetarium na stronę pedofilową. Biorą się teraz idę na dole za chwilę i pójdą ze mną egzaminatorem do planetarium na stronę pedofilową. Biorą się teraz idę na dole za chwilę i pójdą ze mną egzaminatorem do planetarium na stronę pedofilową. Biorą się teraz idę na dole za chwilę i pójdą ze mną egzaminatorem do planetarium na stronę pedofilową. Biorą się teraz idę na dole za chwilę i pójdą ze mną egzaminatorem do